Hello everyone, welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to talk about pyramids. Now, earlier in our video on scaling of images, I have talked about pyramids a little bit, but today we are going to talk about it in detail because pyramids are a very important concept, especially when we will be working with a image blending, means adding two images together, or even in the edge detection. These pyramids play a very important role. So let's get on to a spider ID and see what these pyramids are, and let's work with this. Okay, so here this is my normal program. I've imported a Lena image, and you can see here this is a Lena image, right? So pyramids are basically, if you have watched my scaling video, if you haven't watched it, just go and watch it in my scaling video, scaling of images. And but still I'm going to explain a little bit over here. The pyramids are the concept through which we scale up or scale down the images, means we reduce the resolution of the image by certain factor, and in pyramids that factor is mostly by default 2, means we reduce the pixels from both sides by 2 while reducing the image, or if we are increasing the scaling up the image or increasing the size of the image, then we are multiplying the resolutions by 2 to increase its size. There are two factors applied in basically in the pyramid concept, that is cv2 dot pair up method and pair down method. Now by pair up and pair down word, you would have understood what they would be doing. Pair down method will be reducing the size of the image, and pair up method will be increasing the size of the image. So right now I'm going to reduce the size of the image and show you how the image will look like when I will reduce its size. So image 1 is equal to cv.pair down, and it will take a factor like a source image, that is a normal image, and now I'm going to show it. Okay. Okay, what I'm going to do here, I'm going to write str, and I'm going to give it the shape of the image as a window name so that you can understand its shape, also how it is getting reduced. Okay, so I'm going to just write str image1 dot shape. I use str because it's a string. We write a string over here as a window name, so I have to write str, make it a converted into a string form, and the name of the image, that is image1. Okay, now if I run this program, you see we got, this is our original image which has a size of 512, 512, 3, as you can see in the variable explorer section. And we have created this another image, a reduced image of the original image, which has a size, you can see 256, 256 and 3. Now that's how we are reducing the size. But if you see one thing, this was the original image and this is the smaller image of it, and you see it got little bit of smoothened, or maybe you can say blurred, a little bit of blurred. Now if I you know reduce the its size one more time, let's say image 2 is equals to cv2 dot pair down image 1, and I'm just gonna copy it, image 2 dot shape and image 2, and now if I run it, see I got this third image over here. I'm gonna move it a little bit. Okay, now this was the original image, then we've got a smaller size of the image, and then this is more smaller. Now you can't see a window name over here because it's a very small image, and a window name cannot be written over there because of the size of the image. But you see how it is working, it's getting reduced its size by half at both sides of the pixels, okay, in the length and even in the width. And you can see in the variable explorer section, earlier the image was 512, then it became 256, just divided by 2, and then again divided by 2, 128. Now we can also let's apply a pair up method. If I say image3 is equals to cv2 dot pair up method image2, okay, and I'm gonna again give it here image3 dot shape and image3. Now if I run it, there will be a chance that it will not show it because there's some kind of glitch in Python that it sometimes doesn't show the image, but yeah, image is present over there. It processes the image, but sometimes it doesn't show when we pull out lots of images together. So okay, yes, it isn't showing the image right now. Okay, so what I'm gonna do is I'm gonna just comment out other images. Okay, because sometimes there's a thing like it doesn't show together pair down a pair of images. It's a kind of a glitch in the spider right now. Okay, but it will work in the other IDs. So you see we got this image, pair up image basically, and you see this is a lot more blurred. So this concept is only I'm trying to explain is no matter the more you play with the image, like the more you reduce the size or increase the size of the image, you will lose the clarity of the image, and the image will keep on getting blurred, or you can say smoothened. Okay, so this is what happening over here. Now I'm gonna close it. Now this whole concept is called Gaussian blurring, basically a Gaussian pyramid. Sorry. Now this is a Gaussian pyramid, and I can also, let's make a proper program related with the Gaussian pyramid, because I'm going to use this program in the image blending. Whatever I'm going to write a program today, that program I'm going to use in the image blending concept. So I'm going to make it you know, a proper program, because I'm going to import this program into my image blending program. Okay, whatever I'm going to make an image blending program, I'm going to import this program over there. So okay, I've given an image over here. Now what I'm going to do is I'm going to create a kind of a, whatever the image I will get, I'm going to put it in the create a list of it. I'm going to put it inside of the list. Okay, then you see I was keep on reducing the size of the image by a pare down method. Okay, same things happen in the Gaussian, but right now I have to write the again and again pare down, pare down, pare down. What we can do is we can create a loop of it. So let's say for I in range, and let's say I want to go up to 6. Okay, and I'm going to say gp dot append, and we're gonna write cv2 dot pare down this image that we are gonna get from here. That will be gpi. Okay, oh, you know what, we can even break it down. We can say image is equal to cv2 dot pare down, and I give an image over here, and here I just say gp dot append image. So what happening is basically we have created a list named gp, means Gaussian pyramid, and I have passed right now, I have given it a one variable, one value inside of it, that is image, the whatever the array of images I have given it in, and then I keep on appending it with a reduced size of the image. Okay, and I keep on adding that value inside of my gp list. Now that's it. Now let's do return gp. Right, we are returning the list. Now if I just remove all of this stuff from here, we don't need any of it. Okay, this was my original image. Now what I'm gonna do is I'm gonna just call out that Gaussian function over here, and I'm gonna say Gaussian, and I'm gonna pass this image. Right, now I was returning gp over here. I can also do one thing, but instead of returning I can just do cv2 dot show. Okay, and I can say stri over here, and I will write whatever is present inside of the gp. Let's say gpi. Right, it should work. Right, now if I run this program, let's see what happens. Okay, you see I got all of the images over here. Okay, it was a biggest size over here, original size, then I've got this one reduced size of it, then another reduce size, and there are lots of reduce size over here. Let me shift it. This is a lot more smaller. Then again there is one more. Okay, here. So you see I got all of these small sizes and a one go in just one program. That's how we do Gaussian pyramid working. Okay, so I've created a function over here and I did all of it inside of it. So now this was Gaussian pyramid. Okay, now what happens with the Laplacian pyramid is they also get this whatever is comes out of this Gaussian pyramid, it accepts it first, and then what it works on the Gaussian pyramid, like it starts from the smallest of the image and it keeps on subtracting it with its one higher resolution image, keeps on subtracting it, and whatever it gets it stores in its list and show it. So basically it mostly looks like a edge detection image. And let me show you, then you can understand it much more clearly. Laplacian, and again I'm gonna pass out the image over here, and this same program is gonna work right now over here. Okay, except this CV2 dot, I'm sure I don't need it. Now like in Laplacian pyramid, again we are gonna right now we've got a GP list. Okay, there are lots of images of reduced size. So same way in the Laplacian pyramid also, we will create a list named LP for Laplacian pyramid, and in this we are going to store the smallest image of Gaussian pyramid, because I told you Laplacian pyramid works from the smallest image which comes out of the Gaussian pyramid and subtracts it with its high resolution image. Okay, so I'm gonna give it a, you know, the smallest image of it, which will be GP5, and now again I'm going to use a loop for I in range. Now this loop is going to work from from like endpoint of the GP list to the beginning of the to the 0th index. So it will start from the 5, goes up to 0 with a step of -1, and what it's gonna do is we will find the high resolution image. So to get a high resolution image, what are we gonna do is we're gonna use the pair up method. So same thing we're gonna do here is let's say give it any variable like Gauss, let's say expand one higher image we are taking, so we are using expand CV2 dot pair up, and we are gonna give it GPI. Okay, so whatever that lowest image is, it will find its one high resolution image, and then we are gonna do what we are gonna do is we are gonna subtract those two images. So let's give it one variable. Let's say Laplacian lap is equal to CV2 dot subtract GPI minus 1 comma and Gauss expand. Okay, so now we have subtracted it. Now let's store it inside of our LP list over here. So I'm gonna do LP dot append, and I'm gonna simply write LAP over here, lab, because we are appending this whatever is coming out of lab. And then I'm gonna do CV2 dot show, and I'm gonna give it again I'm gonna say stri as my window name, and LPI the image that we want to print it. Okay, so this is my Laplacian method over here, and now I'm going to write Laplacian image. Okay, and I'm gonna just comment out this Gaussian one. Okay, because right now we are printing the Laplacian. Okay, now if I run this program, okay, there is an error over here. Let's see. Okay, yes, index is gonna go out of range because we are subtracting it, and at the end point it will it will be at 0, but it will be subtracting it, so it won't take it. So let's remove it. Okay, let's print the lab variable. Okay, lab also contains the images. Okay, yeah, you see over here, now these are our images. You won't be able to see the original image because that is not over here, that is inside of the LP index list, sorry, but these are the 5 images, and that's how Laplacian one works. Okay, Laplacian pyramid works because it is subtracting the lower resolution image with a high resolution image. And when you do that, the only difference between those two images is the clarity between that images. And when you subtract them, you get something kind of an edge detection of it. Okay, and those images looks like this, the way they are looking at right now. Okay, if you couldn't see the whatever is inside of this black image, just try to increase the brightness of your phone. Okay, because sometimes yeah, it becomes so dark that you can't see it. But here, it is a lot more clearer right now, because in some images maybe you wouldn't be able to see this whatever is drawn over here, but they are present. Okay, so this is the Laplacian, how this Laplacian works. So now in my next video we are going to discuss about the image blending. With the help of these two methods, we are going to merge two images together, and you won't be able to say that these were ever different. Okay, you will say yeah, they look same, they are same, they were not doctored. Okay, they look same. So for these we are going to work in this, and I'm going to show you its application in my next video. Okay, so work on this and see you in my next video.